Hey everybody, thank you for checking out A1 Math, and today we're talking about similar right triangles, and with similar right triangles, what you have is a right triangle split by altitude that makes two other right triangles. And when that happens and you have those three right triangles, they're all similar. So because of that similarity, we can use that to find missing pieces or missing line segments to find the value of different segments. So I'm going to show you how that works. So there's two rules that you need to keep in mind. One is the altitude rule. Okay, and what the altitude rule is, part of the hypotenuse divided by the altitude is equal to the altitude by the other part of the hypotenuse. So since there's three right triangles, there's three hypotenuses, but we want to refer to the biggest right triangle. So the hypotenuse here is this A all the way to B. That's the hypotenuse. And the altitude is this line here. So I'm going to kind of indicate the altitude here and show you that it is CD and CD. And when we cross multiply, you're going to multiply those two together. It's going to be squared. Now, part of the hypotenuse, like from here to AD, will go here and eventually get multiplied by the other part of the hypotenuse. Okay. So to recap, what you're going to do is take the altitude and end up squaring it and setting it equal to part of the hypotenuse times the other part of the hypotenuse. And that's the altitude rule. Okay, now I'm going to show you the leg rule. So with the leg rule, it's when you have the piece over here on the side. And again, it's the leg to the biggest right triangle here. Okay, now with the leg, there's another word that's in the mix, and it's called a projection. The projection is the part of the hypotenuse that's on the same side as the leg. The part of the hypotenuse that's on the same side of the right triangle as the leg that we're working with. So for instance, let's start with AC. So if you look at AC here, it's kind of taking the place of the altitude, but it's the leg. And it's going to be here and here. Okay, now with that, they're going to eventually multiply or square each other. And we want to multiply the whole hypotenuse here AB, and it's eventually going to multiply against the projection on this side, which is AD. So you'll take the AC, square it, and set it equal to AD times AB. Now you can do the same thing for the leg on the other side, CB here. So CB will multiply against each other. And again, you want to do the whole hypotenuse AB and it's eventually going to multiply against the projection on this side, dB. Okay, so this is again similar right triangles with the altitude rule, where you take the altitude and square it and set it equal to both parts of the hypotenuse times each other. And you have the leg rule, where you take one of your legs, square it, and set it equal to the projection times the whole hypotenuse. And I'm going to show you that in action with some real numbers in just a moment. Okay, now here's our next part in doing similar right triangles, where we're going to use the leg rule and the altitude rule to find the missing pieces. So the first one I'm going to start off with is the leg rule. So remember, with the leg rule, you're going to have the hypotenuse over the leg set equal to the leg over the projection, which is part of the hypotenuse that's on the same side as the leg. Okay, so let's take a look at what that looks like now. Let's start off with the hypotenuse. Well, across from the right triangle here, the biggest right triangle is X. That's the hypotenuse, so I'm going to put that here. Okay, below that is the leg, and the leg is right here, so we're going to put 136. Set equal to, again, the leg, 136, over the projection, which is on the same side as the leg, but part of the hypotenuse, 64. Okay, once we get here, we're just going to cross multiply and solve. So I'm going to cross multiply here, and I have 136 squared is equal to 64x. And 136 squared is 18,496 equal to 64x. And now we're just going to divide by 64. And cancel out my 64, leaving x is equal to 289. So 289 is my missing hypotenuse here. And based on the numbers that I have, it seems to make sense that this is 289. If you solve this and you get 36 here, and this is 64, you could tell that's not correct. So the 289 seemed to be proportional with everything else. So just like most things we do with similarity, you set up a ratio and you cross multiply trying to find the missing piece. Okay, now this was the leg rule. Now we're going to take a look at the altitude rule. Okay, with the altitude rule, what we want to do is set up part of the hypotenuse over the altitude and the altitude over the other part of the hypotenuse. Okay, so notice how the altitude is labeled here instead of the legs. So that's how we know to use the altitude rule. We will take our part of the hypotenuse, and it doesn't matter which part or which order, but I'm just going to start with the 9. Put it over the altitude, which is 12, and set it equal to 12 over the other part of the hypotenuse, which is x. Now, the x could be in a lot of different places. The x can be the altitude, it can be the leg, can be the whole hypotenuse like it was in the last example. But what stays the same is how you set up which piece goes where. So if your x happens to be here where you cross multiply, then you just have x squared. And to solve for x squared, you're going to take the square root. So don't let that throw you off. But on this problem, we got our x here. We're going to cross multiply and solve for x. So here we get 12 times 12, which is 12 squared, is equal to 9x. Square root of 12, we get 144. It's equal to 9x. And then we're going to divide by 9 and get 12 is equal to 16 is equal to x. Right, and that seems to make sense here. Maybe not on my drawing, but this piece here is 16. So again, that's the altitude rule. And if you forget this, keep in mind that with the altitude rule, you'll come down the middle and square this part, set it equal to these two. And with the leg rule, you're going to square the top part of the triangle, 136 here, and set it equal to this side, or the projection up from the leg, times the whole hypotenuse. Okay, now in future videos, I'm going to go ahead and show you how to do more complicated problems similar to this using the same ratios. But for now, thank you for checking out A1 Math. Have a nice day.